This video is on graphing radical functions. I'm going to be doing a couple of examples of just graphing square root functions. Before I begin doing any work, I want to actually look at what this graph should look like in the calculator. I'm going to get my calculator. I'm going to go to my y equals. I'm going to type in 2 times the square root, so I'll just put the square root symbol, x plus 3, and then because my calculator, it extended the radical symbol, I need to make sure that that minus 1 is on the outside of that radical, so I'm going to press the right arrow key to get out of the radical, and then put minus 1. I'm going to make sure when I graph it, I'm going to press graph so I can at least look to see what the graph will look like. And this is a square root curve. Notice that it stops right here. It does not keep going, because if we remember, you cannot take the square root of a negative and be able to see it on the calculator. The square root of a negative value is an imaginary number, which this will only show real values. The reason why it's over here, making it negative, because even though we have a negative 3 or a negative 2 or a negative 1, when we plug that x value back into the radical, we'll still be taking the square root of a positive value. But if I were to say something like negative 7 plus 3 is negative 4. So I would be taking the square root of negative 4, which would be an imaginary value. So I at least can see what the graph will look like. I'm not just going to sketch a basic graph here, I'm going to actually get coordinates. So before we get the coordinates from the calculator, let's talk about the a, h, and k like we did in the last video. Our a value, we need to determine if it's positive or negative. So since we have a 2 here, we know that a value is a positive, but a value is also equal to a positive 2. So I can separate them as a positive and a 2 because these tell us two completely different things with regards to transformations. Our h value comes from the inside of the radicand, or the inside the radical, the radicand. What value will make the inside equal to 0? So if remember, it's x minus h. So it would be x minus a negative 3 to get us to that plus 3. So h would be negative 3. And we know that negative 3 plus 3 would give us 0. Our k value is what's added or subtracted to the outside, so the negative 1 is out here. 1 is being subtracted, so our k value is equal to a negative 1. The reason we want to know this is because the h and k value, since this is a square root, the h and k value are actually confining our domain and range. And if we look back at our graph of this, our h value is at negative 3 and our k value is at negative 1. If we look at our coordinate, negative 3, negative 1, that's actually that starting point of that square root symbol. That's what we want to use for our table. So we can actually find a table of coordinates to graph that will be accurate on our coordinate plane by going to our table. So I'm going to press second graph and actually get coordinates. Now I have some x values here and some y values here. I know from that h and k value, negative 3, negative 1, that's actually where we want to start from, because that's what confines our domain and range. So I'm going to go to that x value of negative 3, and I see negative 3, negative 1, which is that coordinate that we had found from our h and k. Now, if I scroll up further, I have x values because x values are independent. The y values, however, are errors because no matter what, I cannot take the square root of a negative value in the calculator. So what I do is I find the coordinates that I can actually graph. So negative 3, negative 1 is a coordinate that I can graph. That is actually our starting coordinate. So the x value is negative 3, y value is negative 1. That is our starting coordinate. Then I can find other coordinates that we can use to be able to graph. So negative 2, positive 1 is a good coordinate to be able to graph. I can scroll down. So negative 1, 1.8 is a little bit difficult to graph. So it would be the 0 and the 2.46. But 1, 3 is a good coordinate to be able to graph. So 1, 3. Scroll down. So the y value is a little difficult. Y value would be a little difficult. The y value would be a little difficult. And then we have 6, 5 we can graph. So I know that I have up to 10 spaces on here, or I can even change my scale that I want to count by. But I just want to go up to 10 if I can. So we can see that after 10, it gets a little bit harder to graph. So 13, 7 would be the next coordinate. So I'll write that down. But I might not be able to graph it. So I know that I have at least 4 coordinates that I can graph. So on my coordinate plane, I'm going to come over here and graph these coordinates. Negative 3, negative 1. is my first coordinate, -2, +1, 1, +3, 6, +5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And I know that I can't graph 13, 7 on this graph because I have only up to 10. So my graph, if we remember from, or if we recall back from the graph itself, it's going to start at this coordinate and go on forever to the other side. So that means that I will actually make it start at this coordinate and have nothing underneath it, to the side of it. I'm going to start here and then connect my coordinates onwards. And I'll put an arrow on there because I know that will go on forever. Now, because we have our graph and because we have our a, h, and k, we can determine our domain and range. Because this is an even root, again, it's confined by the h and the k. So the h value will tell us our domain and the k value will tell us our range. So if we're starting here, that -3, that h value of -3 is your smallest. It is your smallest value of the x's because I can't go any further in the table. So I know that my domain starts at -3. And then it will keep going to the right forever, so I know that that's going to keep going to that positive infinity. For the range, I need to know my smallest or largest y value. My y values will keep going up, but my y values will stop at -1. So I know that -1 is actually that starting y value. So my range will be from -1 to positive infinity. We know it stops at -1, but it keeps going to positive infinity. So the last part that we want to look at is the transformations from the parent function. This again comes from our a, h, and k. That's why we always write these out. So if the a value is negative, it will reflect. Well, the a value is positive, so it will not reflect. But the a value is a 2. So if we remember back from here, the parent function is y equals the square root of x. If a is 1, there is no reflection and there is no dilation. But the a value in this case is a positive 2. There is no reflection, but there is a dilation. So we do have, since a value is 2, we have a dilation, which in this case will be a vertical, it'll be a vertical stretch because the a value is larger than 1. So it'll be a vertical stretch. And it's of 2, because that's our dilation. We also have the h value of -3 and the k value of -1. So the h and the k value tell us our translations. If the h is 0 and the k is 0, that's where the parent function comes from. But because we have an h and a k, it's going to be translating left or right, and it will also be translating up or down. So since the h value is -3, it will be having a translation of, since h is -3, that's horizontally negative, so that's going to be a left 3. And then we're going to be translating our k value as a -1, which is vertically down, so we're going to be translating down 1.